Hi everyone, welcome to our second 4.4 lesson. So we're looking at, in our second part, we're looking today at mixed radicals and entire radicals. What are they and how can we go back and forth between the two? So this is part 2. Hopefully you've watched part 1 and you've tried the questions in your 4.4 worksheet for parts 1 and 2. And now we're going to do the second lesson and then finish up our 4.4 worksheet. So entire radicals and mixed radicals are exactly what they sound like. An entire radical means that the entire number is inside the root symbol, or the entire number is shown as the radicand. So here's some examples. The square root of 64, okay, the entire number 64 is inside the root symbol. Let's do square root of 128. Again, the entire number is inside the root symbol. Cube root of 32. The entire number is inside the root symbol. In other words, we don't see any number out front, in front of the radical. So we don't see, 2 square root 5 or something like that. Okay. We could also have the fourth root of a number, fifth root, fourth root of 80, for example, is an entire radical because the entire number is being shown inside the root symbol. A mixed radical is different. A mixed radical has a number inside the root symbol, but it also has a number in front. Okay, so a mixed radical would look like this, for example, 9 times the cube root of 4. All right, that's a mixed radical because some of this number is inside the root symbol and the other part of this number, of the product, is outside and it's not being cube rooted. Okay, another example is 2 square root of 2. When you see numbers together like this, it actually is telling us that we're multiplying them together. So 9 times the cube root of 4, 2 times the square root of 2. But what we've actually done is we've taken out a number that was inside, okay, the radical symbol, and we've moved it out to be out front because it was a perfect square. Or in this case, we had maybe the number 27 was inside and it's a perfect, or not the number 27, sorry, 9 cubed was inside. It's a perfect cube, so we've taken it out. Okay, I'll erase that for now to keep it simple, and we'll look at how we do this in just a moment. But really easy then to recognize a mixed radical is one where there's a number out front that is not a radical and a number that is a radical. So it's appearing inside the root symbol. Okay, so that's the definition of entire radicals and mixed radicals. Let's have a look at converting them. Okay, we're going to start with the easiest way, which is if you have a mixed radical, it's really easy to write it as an entire radical. Okay, so this is an example of a mixed radical. We would have 2 square root of 2. Okay, I want to write that as a mixed radical. In other words, I want to put that whole number inside the square root symbol. And the question is, what will that number be? Because it's not going to be the square root of 2. It's going to be a number bigger than 2, okay, inside. So when you want to bring the number out front inside the root symbol, you have to look at what root you're taking. Okay, and you are going to, before you can bring it inside, you're going to have to raise the exponent on that number on the outside to whatever that root is. So another way to say that is you look at the value of the index, and in that case, for this one here, the value of this index is a little invisible too. And that tells you the exponent to raise the number to before it can be brought inside. So let's do that exact same example together right now. So we have 2 times square root of 2. I want to write it as an entire radical. So remember for a moment, okay, that the index is that little number inside the pocket, and when it's a square root, it's often not shown, but that's the index. Okay. Before I can put this number 2 inside here, I have to raise it to this index, or that exponent of 2. So I'm going to, before I bring it inside the root symbol, I'm going to have to square it. So what I get is this. Square root of 2 okay, which was my original number inside the root symbol. And now, instead of timesing it by 2 on the outside here, if I want to bring that inside, I have to square that number before I bring it inside the root symbol. And so what I'm going to get is this. It's going to be square root of 2 times, well, what's 2 squared? 2 squared is 4. And my answer is going to be square root of 8. Okay, there's my entire radical. That's my final answer. You might ask yourself, why do I have to square that number? Why can't I just bring it inside? If you think about it for a minute, this number here, 4, if you wanted to square root 4, it would give you 2. So if you wanted to bring that 4 out of the root symbol, 4 is a perfect square. And so if I wanted to bring it outside of the root symbol, in other words, square root it, I would have to ask myself what number multiplied by itself gives me 4, and that would be 2. Okay, so in order to get it out, I'd have to square root 4, okay, which would give me 2. So before you can go back in, which makes sense, we're just kind of working backwards here. If I want to bring a number inside a root symbol, I have to raise it to that exponent before it can go inside the root symbol. So that if I were to take it out again, it would give me the same number back. It has to still give me 2 when I square root it. Let's do another example. Okay, let's do, for example, let's do 3 times the square root of 10. Again, if you don't see that little index of 2, okay, sometimes putting it in for yourself is really useful. So I want to represent this as an entire radical, which means I want just one number inside the radicand, or inside the root symbol, which means that it is square root of 10 times 3. If I want to bring that 3 inside, I have to square it. So we get 3 squared, which is 9, times the original 10 that we had in here. And so our answer is going to be the square root of 90. Perfect. Let's do another one. Let's do something that's not a square root. Let's do this one here. Let's do the 3 times the 4th root of 3. Okay, I want to write this as an entire radical, which means I want everything to be inside the root symbol. And I want to make sure I remember this is the 4th root. So I need to put that index of 4 there. So I already have a 3 inside the root symbol. It's not going anywhere. What I want to do now is bring that 3 out front in. And before I do that, I have to raise it to this exponent. So I'm going to raise it to the exponent 4. Okay, so I'm going to get 3 times 3 to the exponent 4. And so in my calculator, I could do that. 3 times 3 is 9. Okay, 9 times 3 is 27, and 27 times 3 is 81. Or I could just do it in my calculator quickly as well if I wanted. So what I get there is 81, or 3 times 81, and the answer to that is the 4th root of 243 as an entire radical. Okay. Great. At this point, if you wanted to pause this video and try part 3 of your worksheet, you can, or you can finish and carry on. And we're just going to go the other direction now, working with an entire radical. How do I get it into a mixed radical form? And then you can go ahead and try those questions. Okay. So if I have a mixed, pardon me, if I have an entire radical, how do I get it into a mixed radical? Well, let's think of an example for this. So I could have, for example, let's do the square root of 8, which you could try right now in your calculator, and it doesn't give you a nice integer number. Okay, the cube root of 8 is equal to 2, but the square root of 8, the number that would multiply by itself to give me 8 is a long decimal place that I don't see repeating or terminating, so it actually turns out to be an irrational number here. So you could try that square root of 8 and say, that doesn't give me a nice answer. I could represent this radical as a mixed radical instead of an entire radical. So what I'm asking myself to do is there a factor of 8, okay, that is a perfect square that I could bring outside of the root symbol. So think about the factors first that make up the number inside your root symbol. Then find a factor that you could take the root of to bring outside the root symbol. So if it's square root symbol, we're looking for a perfect square. If it was a cube root, we'd be looking for a perfect cube. So let's think about the factors that make up 8. Okay, and again, you could on your own, if you wanted to do prime factorization of 8, you could. 1 times 8 is one that we won't really use, but 2 times 4 is a factor of, both of those are factors of 8, and 4 is a perfect square because 2 times 2 gives me 4. In other words, 4 is equal to 2 squared. So I could rewrite this as, instead of 8, I'm going to write it as 4 times 2, which is true. Okay, those two factors will give me 8. One of these factors is a perfect square, and so I can bring it outside of the root symbol. Okay, so I'm thinking to myself, well, 4 is 2 squared. So if I square root 4, I can bring that 2 out front of the root symbol. So square root of 4 is 2, which leaves me with just square root of 2 left over. Okay, and I've written it as a mixed radical. Okay, let's try another example. Okay. Let's do square root of 27. Again, you might try this in your calculator. It's not a perfect square, 27, so it doesn't give you a nice answer. It gives you a long decimal. Instead, we're going to say, let's write this as a mixed radical. Again, we can think of the factors that give us 27. What are the factors of 27, other than 1 and 27? Start with 2. Well, 27 divided by 2 is 13.5, so that's not a nice whole number factor. But I could go to 3. 3 times 9 gives me 27, and 9 is a perfect square because 3 times 3 gives me 9. So 9 times 3 can be written inside my root symbol here. Why? Because 9 is a perfect square, which means I could pull out a 3 from my square root symbol. So I'm going to write this as a product of factors, 3 times 9, or 9 times 3. Okay, and I recognize that 9 is the same as 3 squared here. Okay, 9 is a perfect square. And so when you have a perfect square, you can square root it. Okay, which means I can bring that 3 out front. And once I take that 3 out front, I have undone the squaring because I've taken the square root of a perfect square, which leaves me with just 3 on the outside. And there's a square root of 3 left. Okay, I still have this here. Another way to think of it is like this, folks. The square root of 3 times 9 is equal to the square root of 3 times the square root of 9. Okay, I can also break that into 2 parts here. It's the same thing. It's still true. The square root of both of them times by each other. And so what I have here is square root of 3, which I can't go any further with. But square root of 9 does give me a nice whole number. It's 3. And so that's equal to 3 times the square root of 3. Okay, I'm just putting it in a different order now with the whole number in the front. So there's more than one way to think about doing these, okay? But you're looking for a perfect square in these cases here. Let's do one more example where maybe it's not a square root, it's a cube root, okay? So one last example here. I'm just going to go ahead and add a clean page in. So let's do it. The third example I want to do with you is this one here, cube root of 54. This is an entire radical. I want it written as a mixed radical. Again, think of your factors that give you the number 54. So what are the factors of 54? So again, I could do my prime factor tree if it helps. Okay, start with 2. 54 divided by 2 doesn't give me, oh, it does. 2 times 27. Okay, so I say, okay, there's one factor. Let's try factoring out 27. 27 divided by 2 isn't going to work, but 27 divided by 3 will give me 9. So 3 times 9 gives me 27, and then 9 is 3 times 3. So what I recognize here is that 27 is a perfect cube. If I bring that 3 down, 27 is equal to 3 times 3 times 3. That's 3 cubed. And you might have already recognized, if you're familiar with cube numbers, you might have said, hey, I know 27 is a perfect cube. It's 3 cubed. The trick here is recognizing which of your factors are a perfect cube. Why am I looking for a perfect cube this time instead of a perfect square? Because I have the cubed root of 54. So the only numbers that I can bring outside of this root symbol have to be perfect cubes. So you're always looking at the index here to tell you whether you're looking for a perfect square or perfect cube. So in this case, a factor tree is really helpful because it does show us, okay, which factors are perfect cubes or perfect squares. And in this case, 3 is a perfect 3 cubed gives me 27, so 27 is a perfect cube. So let's rewrite this as, this is the cube root of 2 times 27. Okay, and again, I recognize that 27 is the same as 3 cubed. That's what that is. Okay, and so I could also write that this way. That's the cube root of 2 times the cube root of 27. Okay, and so I get 3 for the cube root of 27, and I'm still left with the cube root of 2 can't be simplified anymore. Okay, but times by 3 because cube root of 27 is 3. In other words, I can bring this number out front. All right, and it becomes just a 3 when I cube root 27. And so my answer is going to be 3 times the cube root of 2, which was the only number I have left over here. All right. I'm going to look at one last section here, so stick with me for a moment, and then I'd like you to try some of these for yourself on your worksheet. The last thing that we are asked to do in Math 10 is, if I'm given a whole bunch of numbers and they're a mixture of mixed radicals and entire radicals, I can put them in order if I was asked to order them, but I do need to be able to compare them. So we can order radicals. I'll give you an example of a question in which you're asked to order radicals. So let's do an example first. Let's say we're asked to order these radicals. Let's say 2 times the square root of 18, square root of 8, 3 square root of 2, and square root of 32. So I've got a whole bunch of different radicals, 4 of them to be exact, and I want to order them from least to greatest. So I want to put them in order from the smallest number up to the first number. It's sort of hard for me to compare an entire radical and a mixed radical just by looking at them. So for example, you know, I can see this is an entire radical, and so is this one, square root of 32. But it's kind of hard for me to compare a square root of 8 to, let's say, 3 times the square root of 2. What I can do to make things easier is put them all, write them all as entire radicals. And then I'm just comparing the radicands, the numbers inside. So let's go ahead and do that. So there's a mixed radical, and there's a mixed radical. Okay, so let's change them all to be entire radicals. Okay, so I only have to really change these 2 that I've circled. So let's go ahead and change any mixed radicals. So we're going to change 2 square root of 18 to be an entire radical, which means you put the whole thing inside the root symbol. And so this is going back and asking yourselves, well, what do I do with this 2 out front? I need to bring it inside. So before I can bring it inside, this is a square root symbol, so I need to square it. So I get 2 squared times 18, and 2 squared is 4. So 4 times 18 is 72. Okay, square root of 72. We also have to change this one here, 3 times the square root of 2. Okay, I want to write it as an entire radical, so I need to bring that 3 from outside to the inside, but before I do that, I do have to square it because this is a square root symbol. So we get 3 squared inside now, which is 9 times 2. 9 times 2 is 18. All right, great. So now that I've changed those 2 mixed radicals, now I can compare them. So now I have I've got square root of 8, square root of 32, square root of 72, square root of 18. Now I can put them in order. So in order, least to greatest will look like this. Well, the smallest number on the inside there is square root of 8, so it will come first. Okay, the next number after that will be the square root of 18. The next number will be the square root of 32. And the highest or largest number there is the square root of 72. So I put them in order and I'm done. Really easy way to do that. So change your mixed radicals to entire radicals so that you can compare them easily. One other way that you could do this is to change all of them to decimals. Now, this is not the best method, only because if you have an irrational number, you're going to have to round it when you change it to a decimal. But you could evaluate all of them and then put them in order. If all you're asked to do is put them in order, that's going to work, because even if you round it, you can still see which number is greater than another number. So we could, here's our method number 2. If I had the same values, so 2 square root of 18, square root of 8, 3 times the square root of 2, and our last one, which is square root of 32. One other way I could do it is I could just change these. I could actually evaluate them all. So get rid of these radicals and figure out, well, what is the square root of 18 times 2? Okay, so that's exactly what it's telling you to do. So I could use my calculator. All right, so I'll use my calculator. And I'll say 2 times square root of 18, okay, which is going to give me 8.485. And then there's some more decimal places, but that's enough for me just to compare. Okay, so again, this isn't totally accurate, this method, but it allows me to put them in order. Okay, the next one on my calculator, I just simply take the square root of 8. That's all I have to do, and that's going to come out to be 2.828. Okay, continuing, there's some more decimal places. The next one is going to be 3 times the square root of 2. And on my calculator, if I go ahead and do that, I'm going to get 4.2426, dot, 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 dot. All right, and the very last one is just simply the square root of 32. And again, I get a number that continues, 5.6568. All right, and so for the purpose of comparing them, I can put them in order. So what's the smallest number that I have here? It's 1. Or sorry, it's this one right here, 2.82, or the square root of 8. The next number in order would be 4.24. The next number would be, okay, 5.6. And the last number would be this one, 8.485. So if I were to order them then, 1 to 4 or greatest to least. Okay, if I go back to my original radicals, this one here, okay, 2.828 was square root of 8. Okay, the next one was 3 square root of 2. The next one was square root of 32. And the last one was 2 times the square root of 18. So no matter which method I use, I get the same order. And so both of them are really effective ways if all you're asked to do is put them in order. All right, I'd like you to go ahead and finish up your worksheet 4.4 now. So you can actually do all parts 3, 4, and 5. And check your answers, make sure you're doing it correctly. And that's all for today. Thanks for joining me, and good luck.